Continuation of the lectures on electrochemistry. This lecture is on cell potential, electrical work, and free energy. So this lecture is just a reminder that you should always be thinking about units because they can always help you get answers correct. In specifically chemistry and physics, you always think about units and how you can get from one unit to the other, and then you don't often have to remember all kinds of crazy equations. You just kind of remember the process. Um, okay, so if there's one simple thing you can remember that will help you in figuring out work and energy from batteries and galvanic cells, it's that work and energy and free energy will all have the same units, joules. So you just need to always remember you're trying to get joules. Um, so, and then if you can, voltage is a measure of how much energy a charge has. So voltage's units are joules per coulomb, where a coulomb is a charge of 1 mole of electrons. Knowing the units will often take you a long way towards knowing equations and relationships between work, energy, and free energy. So now, the work that a battery can do, the work that can be accomplished by electrons flowing through a wire depends upon the voltage difference pushing the electrons. And so we have this term EMF. It's given this symbol down here. It's just electromotive force. It is basically equivalent to voltage. So this EMF, electromotive force, equals a voltage difference, and that equals the work per unit charge. That's the work that you can get out of a coulomb of electrons moving around. And so from this, it should be there. The work a battery can do is QE or QV, because if you multiply charge times voltage, you're going to get work because of the way the units turn out. So you're getting QE or QV equals charge times voltage, and that's work. So there should be there should be an equation that says work equals Q times E, or QV, written on that board. And then, because of the huge number of electrons that flow in circuits, they made a name for the charge of 1 mole of electrons, a Faraday. And a Faraday equals 96,485 coulombs. That's the charge of 1 mole of electrons. It's pretty easy to get a mole of electrons to flow in a battery. So charge is typically expressed by multiplying the number of moles times a Faraday. So if N is in moles, then NF is going to equal charge. So work will equal Q times V, and Q is going to equal NF. So you're going to get work equals QV equals NF times V. So we'll take a look at some problems done using this equation in the next lecture. Thank you.